Looking at number 47, the goal is the same. So right away, let's hit this with the ratio test. So here I have a sub n plus 1 multiplied by the reciprocal of a sub n. And now let's do some cleaning up here. And let's do some more shuffling around. Okay, so let's see. This piece here, I ripped it up into these two parts. So that takes care of this. And this here, I put it there. This one here knocks out with this one there. Let me scratch those off. And then this came to the top, and the negative exponent became positive because now it's in the numerator. And then n squared and n plus 1 squared, since these two have the same power of 2, I combined n and n plus 1 into one piece. And see, these go away. So let's see what's left. So this is what I have. This is here. That's still there. This goes away because I could take the absolute value of negative 1, which is just 1. So you don't have to write it. Now let's take this piece outside. So this is what I have here. That's chilling there. Now here, the limit, as n goes to infinity, well, notice that numerator and denominator have the same degree of 1. So that limit is just going to be the ratio of the leading coefficients, which is just 1. And 1 squared is just 1. So all of that is just 1. So this here, I get back this. I applied the ratio test, and this is what I got. And then we know what we're supposed to do. We're supposed to take our value from the ratio test, and you always set it less than 1, and then you solve. So let's try to solve this here. Let's add 1 to everything. And now divide everything by 3. So this here is our interval of absolute convergence. So let me fill that in. That's your converges absolutely interval. And then how far away are the endpoints? From here to here, they are 2/3 spaces. Divide that by 2 to get 1/3. And that's your radius. Remember that? That's your radius is 1/3. Now for the remaining pieces, we have to test the endpoints. So let's test 0. X equals 0. Let's test x equals 0. When x is 0 in here, 0 times 3 is 0 minus, it's just negative 1. It'd be negative 1 to the power. So let's see what we have. When x is 0, we have the infinite series. And we said that'd be negative 1 to the n over n squared. Here, to combine those two, you add the exponents. So this would be negative 1 to the 2n minus 1 over n squared. So I have to know if this series converges or diverges. But remember one thing. If you want to know if a series converges or diverges, take the absolute value of it. So if I take the absolute value of this, negative 1 to this power, if I take the absolute value of negative 1, it becomes 1. So it's just 1 over n squared. So I took the absolute value of this, and it led to that. And because 2 is greater than 1, by what we call the p-series test, I think that's something that you guys discussed in class, the p-series, where if you have a series that looks like this, if the exponent is bigger than 1, then by the p-series, it converges. So since the absolute version of that series converged by the p-series, then we say that the original converges. That's the condition. Remember that? If something converges absolutely, then the original one converges. So the conclusion of the matter is that when x equals 0, we have convergence. So what I'm saying is, for your interval of convergence, which is at least the absolute interval. At 0, it worked. So I put equality there. Now let's test 2/3. X equals 2/3. Plug in 2/3 for x in here. 2/3 times 3 is 2/3 times 3 is 2. 2 minus 1 is 1. So it'd be 1 to the power of n, which is just 1, which disappears. So you basically get this back. You basically just get back this here for when x is 2/3. But I could apply the same technique to this. I could take the absolute value of this and it'll look just like that. And again, by p-series, the absolute value version of this would converge by p-series. So again, at 2/3, we have converges. So boom, I have converges there. And for conditional convergence, there are no such values. Conditional convergence happens when the absolute value version diverges, but the original converges. And boy, that is one heck of a technicality. And yet, problems like this require so much practice because there are so many moving pieces. But for now, just keep practicing, keep studying. And why don't you try number 48?